Yeah, g'day and welcome back to my channel. Now, making a replica of a 1920s motorbike engine from just a couple of pictures might turn out to be a little more difficult than I thought. Who would have thunk? When we left off last week, I had cast a dozen pistons, and of that dozen, I ended up with these 5, which are basically piston shaped, but all of them look like they got pretty crappy defects in them. So I reached out to the old foundry guy, Martin, and he gave me a very detailed, excellent feedback, listing a whole bunch of things I need to address. So let's go through them. Throughout this video, keep an eye out for all the parts I print on this Bambu Lab's X1 carbon. It's amazing how much this helps with the whole pattern making process. So the first point of advice from Martin is, I think you're trying to do too much at once. Yeah. He got me on this one. Because I had a flask that was the perfect height and could fit 3 patterns, I set up to do 3 patterns at once and tried to get all of the pistons I was going to need in one session. And as he pointed out, when you're doing a new part more complicated, I would have been much better off to have just done 1 or 2 parts each session until I'd got some sort of stability in the process and then gone ahead and tried to do a bigger batch. One of the first things I'm going to do here is cut down from trying to cast 3 at once to initially just do 1 at a time. Now, Martin's second input was concern with this idea of having 3 patterns casting off a single sprue. Now let's take a bit closer look at my whole feeding system and what I did wrong. First up, pouring basins. Martin is a big fan of Dr. John Campbell's stepped pouring basins, and that's what I've tried to do each time here, but I'm just carving them out by hand, and there's quite a lot of variability to them, of course. I think I roughly got the shape on this one, maybe a bit too deep a step to it, doesn't need to be that big. This one's not so great, it's more of like a ski jump ramp to allow the metal to blast off into the air. So to address weaknesses in this part of the design, I've whipped up this little core mold here to give in the outside with a hole that makes the top of the sprue, and then this little stepped basin here with a nice big radius down into the sprue. By the way, some of you might not know who John Campbell is, so if you Google John Campbell casting, he's basically the world's kind of #1 research expert. He's got a double doctorate from, I think, University of Birmingham, spent his whole career specializing in trying to analyze and quantify casting. He put out a book in like 1991, I guess you could consider that an Old Testament. Then in around 2001 or so, he put out his 10 Commandments of casting, the 10 rules of casting. And then he put out like a more consolidated Bible, including a New Testament sometime later in the 2000s, which is like a 1200 page of everything about casting. Not the easiest stuff to read. I've been sort of trying to wade my way through the 10 rules of casting. Jumps around a bit. There's a lot of stuff that's not applicable to sand casting. A lot of the stuff's more set up for mechanical production casting and stuff, but a lot of good knowledge in there. Right, well, that looks really nice so far. The question is, can I get it out of the mold without it breaking? Or do I have to make it a 2-piece mold? No, it seems to be coming. Alright, probably a little chunkier than it needs to be. This is just going to sit on top. I'll be pouring into here, and this will then go down the sprue. Right, so now I've got the pouring basin dialed in. It's time to make the riser extensions. The improved pouring basin gets matched up with a couple of riser extensions to increase the head of pressure on the mold as well. Right, so next comes the sprue, where the metal flows out of that basin down into the runner system. Now here, this controls the speed of flow to the entire casting process. So ideally at the bottom of this here, you want, for a little casting like this, if I understand it correctly, you would want about an 8mm hole. Two of my castings last time I used this sprue, and it's way bigger than it needs to be. So that one's 8. The one I used was way too big. I thought I was being clever by using a tapered sprue, but this one's still huge. So since then I've made a much smaller one. The really sad thing is, because my first mould didn't fill last time, on my second casting attempt and also on the fourth, I actually switched out the tapered sprue to just a big huge fat one I made out of a piece of pipe, which is like the worst thing you can do. So all of these are out. In a further discussion with Martin, he suggested I make a slot sprue, 10 by 5mm at the bottom, going out to, I think, 7 by 14 at the top. Now, by the way, on a casting flask, the bottom bit is called the drag, and the top bit is called the cope. I have no idea why. And now for my third name drop, I'm using the book by Steve Chastain of how to design and build your own homemade pistons. He's actually got quite a detailed design of how you're supposed to do the gating and running system. And yeah, I totally screwed it up. I mean, he even put a decent photo in his book showing exactly how to do this. But, you know, I actually misunderstood the geometry of that tapered runner and thought it was somehow sort of an optical illusion which made it look like a sort of flat plane. Yeah, oops. What are we trying to achieve with this? If this is the split line of the mould, so as we see, we've got our cope and our drag. We've got our pouring basin with our sprue. We want this to come down into the drag and feed in the drag initially. And ideally, you want this to run off and include a couple of dead ends with tapers in it. The metal flows down and heads off in each direction. The gate across to our casting is going to be in the cope. Now the idea of this is that the aluminium starts running in and probably picks up a wee bit of loose sand as it comes down, especially as it hits the bottom and maybe makes a bit of turbulence. There's probably also a wee bit of loose sand everywhere, and that gets carried past the gate out into these tapered bits which freeze quite quickly, trapping all that gunk in them. As the level rises up in the runner, that's the runner, and starts filling the gate, hopefully then you've got the cleanest possible metal. From the gate, it'll flow through into our pattern. And the second aspect of all this is, at the latest, as the metal flows out of the gate into the pattern, you want the metal to be moving no faster than 0.5 meter per second. I don't really follow what I'm supposed to be doing to achieve that, but it's pretty clear that there's some sort of rules of thumb that if you take this area here as A, if we call that area B, and then these gates, their area C. So in the 10 rules, Dr. Campbell gives some ratios for this, but I kind of got confused. It seems it's not an exact science. So had I been using the correct sprue, which I wasn't, I would have come out of 4mm squared times pi is 3, so 4 squared 16 times 3, about 45 square millimeters here, and I went into 10 by 10 is 100 times 3 is 300. So all of those rules of thumb are in the sort of range of sort of 1.5 to 1, but I was using 6 to 1. So no surprise that didn't work. And if you're wondering what my design analysis was which led to this design, it's 3 3D printed parts glued to a board, being too lazy to go back up and redesign it in CAD and printing something properly, bodging up something out of a piece of wood, super gluing in place, and then sort of roughly fairing it all in with some automotive bog. That was my process. Right, so the board's good, but let's start fixing it. Boy, that really did stick better than I expected. Let me just bog that board back flat again. Right, it's the next day, and I've had another discussion with Martin, the old foundry guy, because I was just confused how starting with a small sprue and then splitting that flow into 2 directions means I need to halve the runner size. And even if I go up slightly on the sprue size to compensate for the 90-degree turn, I end up with a 3mm thick sprue. And I was kind of concerned that might not work. Of course, it'll get glued on the backside. Martin came back with the practical advice: make one 3mm thick, make a second one 6mm thick, which is currently on the printer, and try them. Good idea. So I'll do that. These are the gates. They'll be glued on the front on this side. I think I'll just drill a couple of small holes through my board just to give me a target to glue this on the back side. Once I got all the bits glued on my match plate, I gave it a quick spray with some quick drying spray paint, and then it was off to the foundry. That's in my little garden shed, which unfortunately has a door too low that I keep smacking my head on. My sand lives down here, under the moulding bench, which has a hole in it, so I can dump sand straight back down into its container. This is my little sand muller. I made this before I got into YouTube. It's a heavy wheel to sort of smush down the sand, and then a plow to sort of flick the sand back in front of the wheel. This isn't perfect, but it really is the key to enjoying casting. As long as you stomp mulling the sand after each time, it's really not fun. It's driven underneath by a 3-phase motor through an industrial angle gearbox. I put a little 1/2 horsepower single phase to 3-phase VFD in this control box. It does a really nice job of reconditioning the sand between each casting. This feels a little bit damp, but in winter the only way I can dry it out is by doing a casting. In summer it tends to dry out on its own. I put a dump door here on the bottom of it. Right, let's start moulding up the first attempt.
Music is love, and love is music. Yeah. Sing the song, brother, sing the song. Sing the song, you could never be wrong. Yeah, yeah, yeah.
Oh darn, that's upside down. I moulded the cope first instead of the drag. Oh well, throw that out and start again.
Now I'm dancing to your vibe. I'm holding it forever, like a treasure from the tree, right from the tree. My body ain't confused no more. Do you hear that? I'm looking at the sky, see the spark and singing. I've been waiting for a sign. Gotta move your feet.
When it comes time to strip the patterns out of the mould, this is where we get to the next piece of guidance from Martin. At the moment my paint gun's the only air pistol I've got with a regulator, so I'll use that for today. During the edit I found I'd failed to film the clean out of that first mould, but don't worry, I've got it on the second one. I was afraid of leakage around my riser extensions, so I put a little bit of sand around there. Don't think that's necessary. At over 680, with the temperature slowly rising, this pour was too hot. So this first pour has the 3mm runner down below, and it's quite easy to keep the sprue fill for the whole pour. Whereas on the second one with the 6mm runner, you can see about now that the runner empties the sprue briefly. I should have poured a little bit faster at that point. Not having a source of exothermal powder, I did try heating the sprue extensions with the gas torch. I don't want the silica bound sand contaminating my green sand too much, so I'll try and knock the worst of these pouring basins off before it goes back into the muller. With so-called green sand, water binds with the clay, making it sticky and holding the sand particles together. And of course the heat of the casting boils all of the water out of it, turning it back into a powder. So between each use, all you have to do is add a bit of water to it, mull it again, and then it's ready for the next casting. But because the rest of my sand is actually a bit moist at the moment, I'll dump this dry sand into it, mix it up a bit and remull it to drop the average moisture level. So while my first mould had sand which felt slightly too moist, I think this time I got my sand slightly on the dry side. You'll see it's a little bit crumbly at the time I demould my patterns.
But I love the most stay alive. That is my latest jive.
Here you can see what I mean by the sand being a little more crumbly this time, not having quite as much green strength.
This is our latest jive. Past is far, yet the past is near. Yet the past causes a lot of tear. And the brother would say, we won't survive, but I love we must stay alive. Enchanted heart. Mankind living like this in our daily.
Looking at this in the edit, I also need to be a lot more careful about pulling things out vertically. Also, I can see in the edit that when I open up the mould, I wiggle there a little bit. That probably also knocks off some of the corners. And the same thing happens with removing the match plate. I tried a paintbrush to round off the bottom of the sprue. You can also see when I put in this core that it did go in squarely, so I'm sure I knocked off some sand there. Thinking about it in the edit, I could probably put those cores in place before I open up the mould, and then I could blow out sand on the backside before I close it again. I did blow down all of my riser extensions and pouring basins to make sure there's no loose sand on those as well. This time I got the metal down at the temperature I was aiming for, around 660. Here my microphone fell off, so I just put it out of harm's way. Because I'd already melted down all my pistons last week with the nice fresh metal, here on its second melt you can already see that this metal's starting to make more dross than the first time. When you first pour, you often get almost like a feeling like it's freezing up in the sprue, and then the material melts its way through and the casting starts feeding. Well, this time it didn't. Also notice again on the 6mm runner that I again struggled to keep the sprue filled. Right, post-mortem, what did I learn? This is the first one I cast. It's only got the 3mm sprue and was cast at 680 degrees Celsius. It was quite easy to keep the pouring basin full. I've got a really bad surface finish on the bottom of the pouring basin. That might have been one I only just made and was still quite wet. Once again, I've got a lot of sand damage or porosity. I'm not sure what that is here on the crown of the piston. I still have trouble with sand, especially while placing that core in there. It's very easy to knock a little bit of sand down into the mould. It's interesting, although this was cast with a very, very thin runner, the metal was fluid enough to actually fill up that tiny little 2.5mm hole through the middle of the pin core, which I found quite surprising. The casting itself is scrap because the core is misaligned. It's been shifted off on an angle. I think my flask is about 1mm too low. I think I need to make a new flask 1mm higher, because when I put the weight on the core, I'm pressing it into the sand, and sometimes I'm not pressing it squarely. This one's not even going to be worth machining. Oh, look at that. Okay, so moving to the second one. Now this had the 6mm runner, and during the pour I didn't manage to keep that full. If you notice at the start, I fill the basin, it starts going down the runner, it takes a bit to melt its way sort of through and then goes with a rush, and my basin pretty much emptied. So for that temperature of 680, I wasn't able to keep this full. Definitely got some inclusions and stuff there as well. In terms of the bottom of the pattern, it doesn't look too bad. One thing I find quite surprising is that the runners always look really good, but beyond that, not so much. Another thing I've also realized is it's actually quite difficult to clean out the bottom of the sprue and make a nice radius joint at the bottom there. And I'm guessing that this is also scrap, because that hole seems to go almost all the way through. I very much doubt that'll clean up. Now on the second casting, I used metal at 660 degrees, but it looks like I had my pouring basin offset slightly from my sprue, and for whatever reason it froze immediately. So that was a fail. And the last one, the 6mm runner, also at that with that cooler metal, definitely still got some defects between the riser and its feeder across into the main casting. Otherwise on the inside, it's probably the best casting I've done. So the question's going to be when I machine this as to whether any of these defects go far enough in to destroy the part and make it unusable. I'll send Martin a link to this video and ask him to troubleshoot for me. Based on this one, I would call this casting session a success though, because I think this is a definite improvement in defects and surface finish compared to the best of the castings I did before. And with that, I'd like to say a big thank you to Martin for his support. I'll keep working my way up the learning curve. Till next time, thanks for watching.